the day. So I understand that you all see my screen. In case you have a problem, please let me know. All right, so welcome everybody. Again, from me, I'm Claudio Scalese, I'm the coordinator for the SNS Joint Undertaking. And now I'm going to guide you on the second part of the day for the brokerage event. This part will be mainly focusing on the different possibilities that are entailed in the platform. So the brokerage event, so it will concentrate on the possibilities of synergies that can be found on the platform between different entities. This resource is operated by the SNS Scope project in partnership with the 6GIA, and is a very good support for us, for all the community, for the forthcoming SNS calls. So for our purposes, there are four main areas that the platform can be consulted. So you can submit proposals and ideas. This is very important. So in case you want to find prospective partners that can ask to join with you for a potential consortium. Also, it's good very submit your expertise, and also looking for potential partners in case you have a common interest and trying to develop common synergies. Very much interesting also the possibility to browse on already existing ideas and submitting proposals. So in case you would like to offer your participation in existing ideas. And last but not least, also to browse profiles and try to have a look also on expertise offerings, and to see if the competence that are presented on the platform can match also your need in your proposals. Few practical details on the second part of the program of today. Again, the event is recorded. To keep your mic muted if you're not presented. The presentation we will have today are 24, so it's important that every speaker keeps the time. So it's 5 minutes per presenter. Normally the presenter will share the. So we are here to help in case you have problems. So we have all your presentations. Remember that 1 minute before the end of your presentation, you will receive a warning just to remind you that your presentation is going to end soon. Unfortunately, there is no possibility for a live Q&A session in this part, but please feel free to use the chat box to answer questions. And we will try, of course, to accommodate with our best effort for the answer from the respective presenters. Here is the agenda for the afternoon session. So the brokerage event is split in two parts. The first part will be moderated by me, and these are the 11 presenters of the first session. In the second part, there will be my colleague Oana Radu that will present and also welcome the next presenters. In total, again, we will have 13 presenters, and if all goes well, the presentation should end by 20 to 4. So from my side, I thank you for your attention, and I would like to give the floor to the first presenter, that is Peter Bercu from IMEC. Peter, the floor is yours.
Yeah, thanks a lot. Can you hear me okay? Can you hear me?
Yes, we can hear you.
Okay. Thanks for confirming. I was starting to wonder. And you're not seeing my slides yet, probably. Now you should see my slides, yeah. So thanks a lot for the opportunity to present at this event. So a short word.
We can't hear you, Peter. Are you muted?
No, we could hear you
We
very
see
well,
you,
Peter.
but we cannot hear you.
It's quite clearly we are hearing him.
We are hearing him.
Okay, it's confusing. So I guess I can continue if everybody can hear me, unless the organizers.
Yes, do continue.
Okay, thanks a lot. So a short word about our research group. So our research group is called ID Lab. So we're part of IMEC and Ghent University. Most of our SNS projects, we join as IMEC because we're also a 6GIA member. We focus on internet technology and connectivity, and also on data science and AI. The group I am representing here is the wireless research group that is part of the technology group. So we're split. Our group is split into teams, or 4 big teams. So we have the deterministic networking group that focuses on TSN, so end-to-end, including wireless. We have the Wi-Fi initiative, which I will shortly.
Can you hear us?
Yes, Claudio, we can hear you. I think the audience could also hear me, but apparently you couldn't. And I think we still cannot. Okay, anyway, I'll continue. Then we have a second large group focusing on 5G and 6G and satellite networking research. And then a third group on IoT and sensor networks. So also the work on joint communication and sensing, indoor localization, and so on is happening in that group. And then across those 3 groups, we have a group working on AI to improve the work that we do in each of those groups. And we have a large group or a large initiative on research infrastructure as well. We don't focus on one vertical alone, so our technology can be applied on multiple domains. A bit of background on our Open Wi-Fi initiative. So we had some problems with the newer Wi-Fi releases, that it was hard to validate new features and to really understand them. Also, in order to innovate, like applying these time-sensitive networking concepts on top of commercial Wi-Fi, there was nothing available on the market. And also to investigate new capabilities beyond communication, such as the joint communication and sensing, was not so easy to do with commercial off-the-shelf chips, because they are basically very closed. The firmware is very closed, so we cannot do a lot there. We could rely on R&D and simulations, but that's, of course, has its own limitations. So that's why we developed our own Open Wi-Fi platform. So it's a full implementation of the Wi-Fi stack up until the baseband implementation. So it really gives us all the functionality that we need to be able to innovate. So for example, here we could build a time-sensitive networking end-to-end, also including wireless nodes such as robotic arms. We could build entire end-to-end connectivity, deterministic connectivity, not focusing on very high throughput, but focusing on very low latency and high reliability. One thing we also do is applying AI and ML-based technology recognition and traffic characterization, radio resource management, such as the sharing of resources in 5G networks, interference avoidance, flexible unicast and multicast systems, and so on. So those are all research areas that we work on. To support our research, we have our industrial IoT lab, where you can see here a picture of. So it basically has some conveyor belts, some robotic arms, turntables, and so on. And also our TSN implementation based on Open Wi-Fi, a private standalone 5G deployment using both Benetel radio units and software-defined radio, so USRPs. We have also an indoor localization system based on ultra-wideband, also very high accurate motion capture system. We can do vital sign monitoring and stuff without attaching sensors to the bodies of the operators We can do gesture recognition, activity recognition, and so on. And everything's interconnected with our IoT Edge Cloud testbed. So you can see there the cloud lab, the virtual wall, and the GPU lab with lots of GPUs to support our AI experimentation. The relevance for SNS calls, so we listed just a few here. So in Stream D, we could supply the wireless time-sensitive networking enablers for industrial automations like collaborative robotics. In Stream B 0, 1, and 2, we could look into IEEE and 3GPP coexistence. So with the testbed that I showed you before, we have both the TSN based on Wi-Fi and Ethernet, and also 5G. Our idea is that both of them have their own use cases and their own benefits. We should look into how can we merge those two worlds, because each world has its own benefits. And then Stream B04, we could look at deterministic end-to-end communication and computing. We have a lot of tools that give you real-time performance insights and application network integration as well. So thanks a lot for your attention.
Thank you. Sorry for the inconvenience with the audio. We just fixed it, so we can move on to the next presentation. That is George Stamoulis from the Athens University of Economics and Business. George, the floor is yours.
Thank you. Can you hear me, please?
Yes, please go ahead.
All right. Let me share my screen as well. Can you see my slides, please?
Yes, you can go.
Thank you very much. So I'd like also to thank the organizers for giving us the opportunity to present our ideas and our expertise and skills. So I'm a head of Services, Technologies and Economics Group, STECON, of Athens University of Economics and Business. So what have we been doing for the past 20 plus years? What we do is that we investigate, develop, and apply incentives mechanisms, cost-benefit analysis, and business models in many application areas, with the most important pillars being telecoms and 5 and 6G, smart energy grids, future internet, blockchain, and cloud computing, and other sectors as well. So what we do is that we work in the intersection of business, economics, and of course, ICT technologies. Our motivation is that the value chains in the digital ecosystems are already very complex, so we need distributed solutions that take into account the possibly conflicting interests of each of the players in the value chain, and of course, the aim of each of them to be sustainable economically, the distribution of information and functionality among these players, the very large scale of the ecosystem, and of course the protocols and mechanisms already running in such systems. So about incentives and mechanisms, just to, let's say, very brief but concise sayings by Meyerson, who won the Nobel Prize in Economics in 2007, that incentives should be considered co-equally with resource constraints in the formulation of an economic problem, and also by Maskin, who shared the same award, that mechanisms can help us attain an efficient outcome, the complicated optimization problem, in a distributed way. So we have 3 pillars of work currently in progress and projects in which we apply our ideas. 2 of them are SNS projects, namely Imagine Beyond 5G and Exigence, in which we do business modeling mainly and design of incentive mechanisms. And actually in Exigence, we also bridge ICT and smart energy grids, in the sense that we are also we have another pillar, which is the smart energy grids, and we have 2 other projects, namely Resonance and Iceland. Again, we perform business and economic analysis and design of incentive mechanisms. We also have we also work in blockchain related projects, and again, what we do is for each of them business modeling, resource planning, and also some technological work related to energy efficiency in buildings and also economic sustainability of such mechanisms. We have designed and implemented a software tool, which we call the 360 BME tool, namely business model evaluation, for cost benefit and economic sustainability analysis. So this is very useful for decision making by market actors and policymakers, because it helps each of the market actor assess first the overall sustainability of a new business model and, let's say, and the economic value brought by a new technology, and also assist the actors understand how the market conditions and costs affect the economic viability of the business models. The objective is to
Half a
reach
minute to go,
all-
George.
Yes. One more, yes, thank you. The objective is to reach all win solutions in which not just the entire value chain is profitable, but each of the market actors. So this business model evaluation tool was spotted by the European Commission's Innovation Radar for its role in business modeling for 5G ecosystem. And as I said, we can assess by means thereof certain very important KPIs as internal rate of return, return on investment, payback period, etc. And also we investigate profitability of the service as a whole, but also of each of the individual actors. And we also can suggest incentives that for actors that are not profitable in the first place to be compensated by other ones in order to attain all win scenarios in which all stakeholders are adequately incentivized. So
George,
this is, yes.
Thank you for
Thank you very much
the
for your
presentation.
attention.
Yeah. Thanks a lot, George, and I remind for the next presenter for the time. So we move on to the next presentation from ULA Communication. We have Hamed Zoir Abdurrahman. So the floor is yours. Ahmed, you are there? We
Hello,
cannot hear you.
I'm trying to
Yes.
switch the screens. Just a moment.
Thank you.
Gene aynısı oluyor değil mi? It seems that I'm not able to switch the screens. Maybe I can do like this. Bitti mi? Ekran mı gitti? Sorry for delay.
No worries. If you have problems, we can try to share your presentation.
Okay. Thank you for Claudia. Today I will be giving a small pitch presentation about ULAC and our interest in SNS projects. So my name is Ahmed Zohr Abdurrahman. I am R&D Innovation Manager at ULAC Communication. So ULAC Communication, founded in 2017 by SESETEC Defense Industry Technology. We are focused on R&D production service and mobile and broadband communication systems. ULAC provides solutions in development, integration, sales, and maintenance to the commercial telco operators, mainly in Turkey. Our LTE base stations currently serve over 3.5 million citizens. This is a significant milestone for nationwide coverage. Since 2021, we have expanded our service globally by launching trial operations in 3 countries with international operators. ULAC has been established in 2017, but prior to this, in 2013, ULAC project began at Aselsan, and as I said, established in 2017. Since then, ULAC has focused on LTE, 5G base station technologies, also SD-WAN solutions tailored for next generation networks. At the end of 2021, launched 6G R&D project. And in July 2022, initiated Vehicle to Everything project, one of our key focus areas with rapid progress. And by the end of 2024, more than 2,000 base stations on air actively used by operators. And January 2025 followed up with the launch of CVTX onboard unit product. So our company focused on development of LTE 5G base station and 5G core network systems and software-based networking technologies, SD-WAN, like software-defined networks and software-defined wired area networks. And we also develop vertical applications in critical domains, and as I said, vehicle to everything communication, public safety, private network systems. As a part of 6G R&D initiatives, we focus patent development for standard essential patents, aiming direct contribution to 3GPP standards. Our R&D team tracks and engages with key topics currently under discussion in 3GPP meetings. Our key focus in 6G research is a multi-input, multi-output MIMO, cellular vehicle to everything, non-terrestrial networks, artificial intelligence and machine learning, integrated sensing and communication, waveform design, channel control mechanisms. Since 2033, we have achieved over 100 patent applications across these focus areas. Through our set-focused effort, we aim to take active role in upcoming 3GP meetings. Our primary objective in 6G research and development are focused on advanced technology from concept to commercialization through R&D conducting research, patent generalization, securing our innovations, standard aligned with the SEP focus innovation in 3GP. And when time comes, we are planning to product develop.
50 seconds, Ahmed.
Sorry?
You have still 50 seconds to go.
Oh, let me speed up. Okay, we have a good engage in academic collaborations. Mainly they are from Turkey, but we are also have a want from Europe partners as well. As I said, we have V2X solutions. We have several European projects also and national projects. We have a UAV-based 4.5G communication. This all already in Turkish Armed Force inventory. Let me come here, most important part. So today we are here actively seeking collaboration opportunities under SNS JU program. Stream B01, Stream B0102, 03, disruptive technologies for 6G, advanced IoT and device technologies, wireless communication technologies, and 6G end-to-end unification integration. These focus areas we are interested in. We are eager to join a strong consortia. I believe we can make a strong contribution with our expertise and experience on these projects. If you're interested in partnership, we would like to have a connect after the session. Thank you very much.
Thank you very much, Ahmed. So we move now to the next presenter. It is Mr. Joaquin Escudero from Gradient.
Hello, this is Joaquin from Gradient.
We can hear you. Please, you can present.
Okay, let me share my slides. Okay, hopefully you see the slides.
Yes, please go ahead.
Okay.
Thanks.
Okay. So what I'm presenting here is well just a brief introduction about Gradient, but what we are sharing here today is a pitch for proposal, and I will go into the details of this in 30 seconds, more or less. So our center Gradient is a technology center, a Spanish technology center in Galicia, and we have three main pillars that are security, intelligence, and connectivity. And we usually focus on medium TRLs, meaning that we usually take the background from the university, and we put that in higher TRLs in the form of demonstrators or even proof of concept more elaborated. So going into the details of the pitch of the idea pitch, we are focusing the target stream is B0302 higher speed optical access networks and future end-to-end packet optical network architecture in 6G. And going more into the details, the main objective here is to develop and validate an optical remote radio unit, so head or remote unit, okay, and to improve efficiency and capacity in 6G networks. So we are incorporating also different components to the fully optical radio unit. For instance, we will try to, one of the objectives is to implement and validate optical beamforming to simplify the remote unit processing. Also, the design of programmable and optical filters. Also redesign a full redesign of the front out, transforming the analog front haul into optic. Develop ultramassive MIMO radios, focusing also in reduction of the number of PIs and well, the ideal outcome here would be that we would produce a radio unit with no power amplifier, but this is initially the idea. Let's see if we can achieve that. Also, the use of AI for automation and resource efficiency, and develop a system for simultaneous communication and sensing. The paradigm we are also trying to develop ISAC functions here and ISAC functionalities, and also the implementation of PUC-ID for secure encryption, and integrating here also this type of key distribution, as we are focusing on an optical system.
Joaquin?
So the main sorry. Yeah, sorry.
It seems that the slides are not moving, so we can just see your first slide.
Oh, okay, so do you see now the main objectives here?
Yeah, please put it in presentation mode.
Yeah, but in presentation mode, I was in presentation mode, so that's the problem, it seems. So I'm going to stay in this mode. Sorry.
We see your main objectives. Yes.
Okay.
Thank
Sorry for that, because sometimes there is this problem. So the main objectives, as I mentioned before, I mean, just summarizing it, the objective is to replace all the radio frequency functions and all these functionalities that traditionally done in a radio unit as radio frequency functions, and transform that into optical components and optical functions. That's the main idea of this project. So what we are, these are the expected outcomes. I think I can skip it. Gradient will be coordinating the project, and we also have Vodafone as a technical coordinator. And well, we are, you can see here our different contributions and our expertise. Vodafone, of course, is an end-to-end operator, end user operator, and but they also bring here their capabilities and their capacities. Okay, thank you. The capabilities in this in research for optical networks. Gradient brings here the expertise in PIC design and system design, signal processing, QKD, and also our expertise in ISAC communication and ISAC systems. And we are currently trying to fill in to complement the consortium with different partners and different profiles. For instance, radio unit suppliers. We are also searching for the cooperation of universities in the field of signal processing, optical signal processing, and advanced informing. We are also looking for partners involved in resource optimization and in software design and implementation and deep tech companies. So just to close this brief presentation, you can contact me or Marta or also Claudio through this email if you are interested in participating in this proposal. Thank you so much.
Thank you, Joaquin. And we go now to the next presenter, that is Mr. Eric Gattel from IRT BCom. Eric,
Yes.
can you hear us?
Yes. Yes.
All
Hello,
right.
everyone.
The floor is yours.
Okay, thank you. Okay. So thanks a lot for this opportunity. I think you can see my slide. Yeah. Yes. Okay. So my name is Eric Gattel. So I'm a R&D project manager on BCom, and I will present you a few slides to introduce BCom and to show what we can propose as possible contribution. So in BCom, we're Institute of Research of Technology. So we are working in terms of to explore, design, and provide digital technology. And the goal is to accelerate some transition. It could be numerical or environmental. We are working on projects, R&D projects, with the topics to have a responsible digital innovation in the service of the decarbonization. So we are working with industrial companies, academic partners to generate technology, knowledge, expertise, and competitiveness. So we are in Rennes, in France, and even if we are in an ERT, we are considered as a SME for European Commission, also for European projects. So what is our positioning? You can see my slide? Okay, it's fine. Okay. What is our positioning? So we are here in this slide, we can see the topics on which we are. Cannot see any slide. Okay. You can see my slide?
Yes.
Yes.
Okay, it's fine. Okay. We are working on 5 main topics. The first one is image, vision, and interaction, artificial intelligence, and cloud, perspective and design, and advanced connectivity for XG connectivity. So we are targeting many verticals as cybersecurity, Industry 4 and 5.0, transportation, logistic, or health and transportation. So, and the goal of that is to provide projects to target such verticals. In terms of European projects, so here we can see a map on previous European projects we are working on to show that we have a lot of experience in contribution, or we could be good partners to be involved in the consortium. Now, in terms of expertise, so here we list the main topics we want to address, let's say, on the SNS projects. So we can work on the MIMO. I don't want to go into details. I mean, I will present the main topics. So we can work on the MIMO processing techniques for the discrete communication using cell-free MIMO, and to work also on a full duplex self-interference cancellation techniques. So we have some PhD on progress on it. And the next step is to design a prototype and go for a POC. We are working on the NTN, non-terrestrial networks. So we are also PhD ongoing for the geo and IoT activities. We are working on the release 18 and 19 specification for the LEO and the broadband 5G NR. And we want also to work on the TN integration. It's a topic we want to address now in the coming weeks, coming months. So it could be also a good opportunity to work on that. We are working on the AI, mainly for the specification on the crash preamble detection, for instance, time and frequency offset estimation. And we are also working on the 5G mic scheduling.
1 minute, Eric. 1 minute.
Okay, sorry. Okay, for the QoS management and slicing, and then for the new waveforms as well, we are working on the ISAC as well, integrated sensing and communication, and we are also delivered some research papers on OCDM, IFDM, and OFTS. Next slide is to show you that also in BICOM we are able to provide XUV testbed. It's a platform on which we are working on the AERU and DU developed by BICOM, and we are complete end-to-end testbed on which we can propose some innovation and to be integrated in such innovation to show XUV 5G or 6G technologies. Next slide, just to show you also what the call we are interested in working with partners on the consortium. So it can be Stream B, Stream C, or Stream D. We are we can add a contribution on all those topics. So of course, I will be happy to give you more details if you want to discuss with me offline. Let's say.
Thank you,
That's
Eric.
it for me.
Thank you, Eric. And now we move to the next presenter.
Thank you all.
Thank you. So next presenter is Femi Emre Kadan from Viavi Solution. Please, Femi.
Hi everyone, can you hear me?
Yes, floor is
I'm
yours.
sharing my screen. Can you see my screen?
Yes.
Yes.
Okay. Hi everyone, my name is Fehmi Emre Kadan. I am a staff research scientist at Viavi Solutions, based in the UK. Our company is a test and measurement company, and our headquarters is in the US, but I am based in UK. In UK, we are generally leading wireless communications part, and I am a part of research group. In our company, we produce some products on wireless and avionics, including mobile networks, some military systems, and aerospace. And we also produce some test products for fiber optics, transport networks, cabling, and we also consider security, sensing and authentication for government, aerospace, automotive, like different verticals. And here you see our product portfolio for the wireless part. We generally emulate some part of the network to test the other part. We consider UE emulation. We support ORAN, so we can emulate DU, RU, CU to test, for example, core networks or RIC. We can also emulate core network to test RUN. So yeah, we can basically emulate any part of the communication network. We have some projects that we are collaborating with some partners for 6G SNS. We have 2 projects, 6G DALI and 6G Twin, which were accepted in previous years. And in our research group, we consider some emerging technologies for 6G. For example, you see 4 different topics: multiple access, ray tracing, AI for RAN, and also ISAC. In last year's MWC, we presented several demos for these topics. You can check our website, 6G forward page, to get more information. And here you see the list of topics for this year's call that we are interested in. For B01, V01, which is about architectures, we are interested in goal-oriented communications and performance evaluation for new architectures using our products. For wireless communication-related call, we are interested in AI-based solutions for RAN, especially focusing on transmitter-receiver design, beam management, AI-based channel and RAN emulation. We also consider waveform and multiple access design for 6G, semantic communications, X-large or distributed MIMO. We are also interested in physical layer security as part of this call, and we can also support the project by POC development for all the topics listed here. For NTN-related call, we are interested in designing new waveforms for NTN, and we can also contribute to performance evaluation and also TN-NTN coexistence. And we are also interested in security-related streams, V04, basically. So we can consider zero-touch automation, mutual authentication, intent-based security. We can contribute testing new 6G APIs related to security and also new security architectures. We can consider quantum security and performance evaluation using considering energy efficiency. And for other calls, CND, we can simply contribute to the project by testing some part of the system by emulating UE part, RAN part, core, traffic, or channel emulation. So thank you for listening. If you have further questions, you can contact our external relation leader, Jyoti Basim. Yeah, thank you.
Thank you, Femi, and also for keeping a very good time of the presentation. So now we go for the next presentation from Antonios Lalas from CERT ITI. Antonios, are you?
Hello, yes. Let me share my screen.
Please.
Can you see my screen?
Yes, please go ahead.
Full screen now, right?
Yeah.
Okay,
Very good.
perfect. Hello, everyone. My name is Antonios Lalas. I'm a postdoc researcher in CERT ITI. CERT is one of the top 20 EU institutions regarding research in Europe. Among CERT, we are in the Information Technologies Institute. It's the first in Greece in terms of competitive projects. We are active in different technology domains: artificial intelligence, robotics, visual and computer analytics, of course, 5G, 6G, cybersecurity, and e-health. Some of our equipment, an autonomous vehicle, etc. Maybe we have also a smart home where we have different technologies installed. Of course, we have there the 5G testbed, the core and RAN, as you can see here in more details, where we can have our experiments regarding 5G. We have a reconfigurable intelligent surface where we are working on different use cases and AI-based anti-jamming and spoofing in terms of the network project, and also human activity recognition of a risk in terms of the AutoTrack project. We can provide a use case, a vehicle teleoperation over 5G. This is our vehicle. We can provide also an anti-drone use case over 5G. This was developed in many cases and evaluated on the field. Here are the projects that we are currently active. We are the coordinator of Arrow, Network, Swarmcatcher, Autotrust, and Cognet, among various other projects. This is our expertise in cybersecurity, cyber physical, blockchain, intrusion detection, penetration testing. A lot of activity in AI-based intrusion detection systems, in attack generation, in penetration testing using AI. We provide V2X enablers for 5G as well. We have expertise in multi-physics simulations for physical layer, RF MEMS, wireless power, and metamaterials. Regarding RIS, we are investigating different use cases with V2X communication and wireless power. We can provide also the anti-jamming and anti-spoofing in conjunction with V2X through various work we have done. We have participated in DCEN's 6G challenge. Here we have provided BIM classification and blockage classification, and we got the 5th place among others. So a summary of our research expertise. We're active in IoT and terrorist communication technologies, visual analytics, machine learning, neuromorphic computing, data anonymization, metamaterials, smart materials, photonics as well. A lot of expertise in cybersecurity, AI-based, cloud-edge computing, also physical layer neuromorphic computing, photonic circuits, and of course RIS and Isaac as well. So we're interested in different domains of the call. In the architecture, we can provide AI-powered and LLM-based multi-agent systems, AI-based optimization, and AI-powered physical layer evolutions and designs. Also, we can provide the physical layer algorithms and channel estimation, physical layer security, Isaac and MIMO use cases, AI-powered automation, among others. We can provide use cases such as anti-drone, anti-jamming for the different calls. We can provide also optimization for sustainability and energy consumption minimization, different solutions regarding security as presented earlier about ITS and penetration testing, CTI as well, and service auditing mechanisms. Microelectronics, here also we can provide ICAS neuromorphic computing, and of course, different kind of verticals, SICAM, health, and industry as well. Thank you for your attention. Thank you for your attention. We'll be very happy to collaborate in upcoming calls. Thank you very much.
Thank you, Antonis. I was just reminded that you still had 1 minute.
Okay,
Anyway,
it was very fast.
Thanks. So we move to the next presenter, that is Mr. Ronis Maximidis from Stellar Phronesis. Ronis, can you hear us?
Yes. Can you hear me?
Right. Yes, very well.
I'm just sharing my slide. Do you see my slides or no?
Not yet.
Still?
Not yet.
Okay. Last chance. Let's see if this will work.
Maybe you can. Yes. Now we can see.
Okay. Great.
Please, in presentation mode.
Yes.
Thanks.
Hello, everyone. My name is Ronis Maximidis. I'm one of the founders of Stellar Phronesis. Stellar Phronesis is a startup from Greece, from Thessaloniki. And actually, what we are building is a high throughput, low power wireless system. And how we want to do it is using photonic integrated circuit. So we are actually designing new photonic integrated circuit with multiple input, multiple output, but I would not say it MIMO. Let's say it's multiple input, multiple output photonic integrated circuit, and we are developing an AI adaptive control over it. So what we are able to achieve in this way, of course, the first, the simplest way, what you can do is the beamforming, what was also represented by a gradient, I believe, that can be done. Also, you can do real-time environmental self-correction and also dynamic boundary allocation. and we are working on all these verticals. Okay, here you see our main expertise. Okay, on the right you see the founders of Solar Furnaces, me, myself, and Christos Morevatos. He is expert in AI and optimization. So we have experience with fiber wireless and antenna arrays, with informers, with photonic integrated circuit and wireless, the processing of wireless signals with photonic integrated circuits, and also AI-driven signal processing. As individuals, we have participated in 4 Horizon projects, 2 on 5G, 5G in 5GAN and 5G FOS, and 2 on photonic integrated circuit processing of wireless signals, parallel, where we are developing a LiDAR and radar, especially the integrated beamforming part, and also Mimosa, where we are developing space optical communication, actually, while photonic integrated circuit was used for MIMO processing. Where we believe that we can contribute, I try to highlight this, specifically the part that are most relevant to us, is this expected outcome of this wireless communication, development of algorithm for massive MIMO system for increased channel capacity, coverage improvement, and under difficult propagation conditions. Here we can actually help with extreme exploitation of MIMO technologies with extremely large arrays, massive MIMO, and also the second scope, which is more interesting, let's say, and closer to what we are doing, is the hybrid analog digital front end, where the analog actually will be the photonic part, which brings also all the power benefits that we know, power efficiency benefits. So what we could do for this project, we could develop the compact low power MIMO photonic processor that works at millimeter wave and terahertz frequencies for channel capacity improvement, and also implement AI algorithm for real-time adaptive signal correction for coverage improvement and for difficult propagation conditions. Furthermore, we could also contribute to high-speed optical access network. Here, the expected outcome is integration of photonic and wireless system, including sensing, with 2 scopes that were identified: integrated with wireless and optical sensing as support for services, and impact of photonic systems in 6G energy consumption and sustainability. Here again, we can develop a compact low-power photonic processor for joint sub-terahertz communication and FSO links, and also implement an AI algorithm for real-time adaptive processing of signal and calibration of the system. And also
1 minute, Ronis, 1 minute.
Yes, I'm done. So if you want more information regarding photonics and antennas and deformers and etc., you can contact me. Regarding AI and integration strategy, you can contact Christos. And if you are in Thessaloniki, you can always contact us and visit us and have a chat. Thank you.
Thank you very much, Ronis. And we now go to the next presenter, that is Mr. Konstantinos Tontin from the University of Luxembourg.
Hello, everyone. Can you hear me?
Yes, please. The floor is yours.
Excellent. Let me share the screen. Just to put it in full mode. You see it in full mode now, right?
Yes, you can.
Lovely.
Please go ahead.
Yes. So, I'm Dr. Konstantinos Tontin. I'm a research scientist at the Signal Processing and Communications Group of the University of Luxembourg. We are a fairly large group. We were created in 2009, and the total estimated budget for last year is around 11 million euros, and we are large also in terms of people. We have around 100 people for 2025 this year that involve 2 full professors, 10 research scientists, research fellows, also several postdocs and doctoral students, research specialists, support and technical personnel, and master students as well. And our main areas of expertise are wireless communications and networking, non-terrestrial networks, and quantum communications. Now, going to our 6G research areas. These revolve around 4 main subjects. First of all, non-terrestrial networks, where we can provide expertise related to antennas and digital performing, satellite payloads, spectrum management and coexistence, and distributed satellite systems, among others. Also massive connectivity that involve reconfigurable intelligence surfaces and massive MIMO. We heavily rely on artificial intelligence and machine learning as a tool in aspects such as radio research management, traffic forecasting, interference detection and mitigation, channel modeling, network management, and finally, quantum communications, particularly the testing of quantum key distribution, so security-related aspects. We are heavily involved in European Commission projects in areas such as unified terrestrial and terrestrial networks, quantum communications infrastructure for security, healthcare 4.0 paradigm, AI-based Internet of Things, multiple antenna communication and configurable intelligence surfaces, optical communications, and distributed ledgers. 3 of those projects that you see are SNS JU related ones, Ether, Terra, Meta, and Xtrust, and we also coordinate the first one, Ether. Now, going to our main expertise, where we can provide the experimentation infrastructure. We first start with Stream B0301 about the integration of terrestrial with non-terrestrial networks. We offer expertise in management and orchestration, dynamic routing, optimization of the system and subsystem level and spectrum issues. We run the 6G Space Lab, that is a facility for the design and testing of 5G, 6G satellite end-to-end space, and that involves multiple 5G, 6G end-to-end related aspects, such as multi-orbit emulation over the satellite, AI acceleration, spectrum sensing, joint communications and position navigation and timing, and joint communication and sensing. And we are very involved in supporting 3GPP standardization activities, starting with 3GPP release 19, and also in several aspects that are discussed for release 20, such as GNSS free operation, and joint communication and sensing, and multi-orbit multi-connectivity. The second stream where we can provide experimentation infrastructure is B0302 about higher speed optical and future end-to-end packet optical network architecture, where from the code description we offer expertise in quantum networking over fiber for transport system and applications. We have a testbed that involves a cross-border connection between Luxembourg and Belgium. We use a star topology and different technologies such as prepare and measure QKD and measurement device independent QKD. We involve different geographical sites and FSO link. And we have achieved several things such as first long distance QKD demonstration in Luxembourg and the demonstration of this terrestrial cross-border connection. And we also use an operated fiber. Going with the expertise that is related to some algorithmic aspects. So we can also provide expertise in Stream B0101 about advanced architecture systems and technologies, particularly related to AI-based goal-oriented communications, and Stream B02 about wireless communication technologies and signal processing, where we can provide algorithmic expertise in physical layer security, massive MIMO, embedded and neuromorphic AI, ML, semantic communications, dynamic spectrum sharing, and open RAN and RAN disaggregation. These are the published works of ours. Yes, I'm already done. So these are some published works that substantiate our claimed algorithmic expertise. And these are our contacts where you can reach us, and we will be very happy to discuss about potential collaboration. Thank you very much.
Thank you very much, Konstantinos. And now we go to the next presenter, that is Mr. Razvan Crăciunescu from the University of Science and Technology from Polytechnica Bucharest.
Hello, yes, I hope you can hear me.
Yes.
Yes, perfect. So I'm going to present you what we are doing here at the Polytechnica Bucharest in the Future Networks Research Lab. Perfect. Yes, so what we can provide to a consortium that wants to take us or to to help them write a proposal. It's a full private 5G SA network. We have both an indoor but also an outdoor infrastructure. We also have a particularity. Our university 5G networks at the core, it's shared between, so we have a radio, the radio part is in Polytechnica Bucharest, but we also have a UPF together with the radio in another university in Romania, in Iași, in the University of Iași. So we can do simulation in both locations. Also, we increased our network. So besides what we have in the lab, that is somewhere behind the photo here, we also have 2 antennas to in order to do use cases that are outdoor. So we have a 5G new radio antenna and 2 5G new radio antenna on this path. That is so this is like a small street inside the university with cars, people, 2 wheels, and we can simulate or we can do use cases related to vehicle to everything or smart city or net zero or everything around this localization, ISAC, and so on. So these are some of our main areas of research. We can do 5G and 6G testbed development. Of course, we have the network that I already showed you, but we also have open source networks like Operator Interface that we have developed and they are operational. We are also keen on or doing research on integrated sensing and communication solutions, mostly from the core part on how to enable ISAC in the radio. Then everything related to dynamic network slicing and programmability, automation and orchestration using AI, security and resilience, and the testing security of applications or further 5G private network, design implementation of mission critical solutions that are already doing in the network, services here in Romania. And also we are part of the Smart City Climate Authority Competence Center, where we are working with digital twin solutions using 5G. These are some of the projects that we are already in. We have a connected Europe facility project where we are implementing 5G in the dynamic delta, but also molecular projects or Norway funds, for example, beyond 5G for Internet of V2X for monitoring services. Can you hear me now better? Yes, no, maybe. Okay.
We have problems to hear you. I don't know. It's a bit the connection, I guess. It's a bit disturbed.
Is better?
Yeah.
Test,
much better now. Yes, thanks.
Okay, much better now. Perfect. So these are some projects that we are in, connected Europe facility, where we are implementing 5G in the Danube Delta. But also we had during the times Marie Curie projects or research project on behind 5G Internet of Vehicles, V2X, drone defense systems or defense system against drones based on software-defined radios, and some project that we have with the industry in testing 5G or different types of 5G. We are part of the Romanian National Quantum Communication Infrastructure Competence Center, where we have a quantum communication infrastructure between big university in Romania, and this is led by Polytechnica Bucharest. And also we are part of the National Competence Center for climate neutral and smart cities. And of course, these are the only competence centers on these topics in Romania. We are also part of our lab. We have other research and development groups from signal processing to AI, also we can also help on integrated circuits and CMOS or decision system and sensor data analysis for space. Where we can contribute, we can be work package leader or task leader for projects inside the stream B, B01, 01, 02, 03, 01. Also stream C and stream D, because we can use the infrastructure that I already showed you, indoor and outdoor, on these two. In terms of use case that we can implement, we have smart city, digital twin, integrated sensing and communication, AI for everything, including smart agents, IoT, smart mobility and transportation, of course, inside our campus. We can bring, so our lab has also a spin-off SME. If you need maybe SMEs from Romania, not a university, and we are collaborating with them. And also we can bring any industry and public authority partner from Romania, either big industry or telco from Romania, or public authorities if they are needed for the use cases. So yes, thanks. You can find me
Thank you very much,
here,
Razvan. And now we go. Thanks a lot, Razvan. And now we go to the last presentation of this session that will be given by Mr. Rob Maunder from Axel.
Next. I don't know who's next.
Yeah, thanks, Razvan. So, Rob, can you hear us?
Yes, I can. Can you hear me?
Yes. So please go ahead. You have the floor.
Okay, let me just get the right file up on the screen. Apologies, I've got too many windows open here. Right. You can see this?
Yes.
Okay, thank you.
Coming in a moment. Yeah. Yes, go ahead, please.
All right, well, thank you for having me. So I'm here to talk about Accelercom. Our particular interest is on 3GPP non-terrestrial networks. So here we talk about the opportunity that 3GPP non-terrestrial networks presents for connecting diverse devices, smartphones, IoT devices, vehicles, building access points all around the world, devices that are built by diverse manufacturers. And there's a proliferation of satellite connectivity that is promised here, as well as a cornerstone for 6G. Our particular focus is on the GNOB, the base station side, and in particular on the physical layer, which we refer to on this slide as the 5G NTN modem. We have a solution that's particularly differentiated for the case of regenerative NTN systems, where the base station is on the satellite. We have a suite of IP, hardware IP, software and interfaces that uniquely run on low power radiation tolerant chips, the sort of chips that are required in order to operate in space. There's a challenge faced for the sorts of chips that are traditionally used to implement 5G base stations, often x86 server chips, for example. They're not tolerant to radiation and they have too high power consumption. So this motivates a much greater emphasis on hardware acceleration and embedded CPU software, which we use in our implementation here. We are integrated with partners who have the rest of the stack, antenna systems and onboard processor devices. We're also interested in other applications that are related to this, lunar networks, high altitude platforms, ruggedized defense applications can also leverage and benefit from the technology we have. Just to tell you a bit about our company, we are based in the UK. We span out from the University of Southampton 9 years ago. We're a venture capital backed company. We've just had a recent investment round closed. We have an ecosystem of partners. So we work closely with Radisys and Capgemini, who have the layer 2 and layer 3 that sit above the physical layer, our layer 1. We have a diverse team with expertise spanning a wide variety of different relevant areas here. And our technology is proven. It's in orbit today in dozens of satellites. We have a number of particular examples we can talk about. So on the next slide, I'll talk about a demo satellite that will be launching later this year, which we anticipate will be the world's first demonstration of a 5G base station in space. We have our technology in a satellite constellation. This is an ASIC implementation of our hardware acceleration. In terrestrial networks, we have our accelerators integrated with AMD devices, and a tier 1 base station manufacturer is rolling that out across a US network. And then we have lots of examples of working with diverse base station manufacturers addressing various applications such as small cells, private networks, stadiums, and that kind of things, using our components in their ASICs and FPGAs. So I'll elaborate a little bit further about our solution, our 5G NTN modem. It comprises accelerators running in FPGA and AI engines for data channel signal processing. We have software that runs in embedded ARM processors for control channel signal processing. We use standardized interfaces from ORAN and small cell forum to integrate with the 5G stack and the RF front end. And all of this is integrated onto low power radiation tolerant devices from AMD and NXP. In our lab, we have an end-to-end real-time automated test environment so we can thoroughly test and prove our solutions. And we have a customer which has built a 5G new radio NTN base station. They've integrated our modem with the Radisys 5G stack, integrated that onto an onboard processor. They've integrated this into a satellite which will launch later this year. We anticipate it will be the world's first demonstration of a 5G base station in space. And in the meantime, they've proven this in their lab. It's gone through all the qualification. They've used channel emulation, and they're able to stream video from one user device to another through this emulated channel. And this represents a really significant head start on the rest of the industry. Thank you. So our interest in SNS JU is across a variety of the different streams. Anything relating to 3GPP NTN is of interest to us. Our technology is at a progressing technologies readiness level. So the opportunity to get involved in trials and demonstrations is of particular interest. So if anyone would like to reach out to me, you can see my email address down here. Thank you.
Thank you, Rob. So this brings us to the end of the first session of the SNS Brokerage event. So I would now give 5 minutes break. So we reconvene at 10 to 3. And we will have the second session that will be moderated by my colleague, Oana. Thank you to everybody and see you soon.
Start the second session of the brokerage event this afternoon. Welcome to each and every one of you. My name is Oana Radu. I'm a program officer at SNS JU, and it is my pleasure to also welcome you to our event. We were very inspired in the first session, which was shared by my colleague Claudio, to hear all the very good presentations so far. And we really hope to have an equally inspired session now that starts now. We have 13 presentations in our session. I would just like to remind a little bit about the housekeeping rules, like Claudio was mentioning before. Each presentation should be 5 minutes maximum, and you will receive a verbal warning from us 1 minute before that time elapses. I would like to pass on the floor to Gary Halstead from AWTG, so he can share his presentation and start his talk. In case there is any technical difficulties at the presenters' end with regards to sharing their presentations, please let me know, and I will oblige to present your presentation from my laptop. Gary, the floor is yours. Can you hear us? Gary? Okay, so apparently Gary is not with us this afternoon. We would like to then move on to the second presentation on the list as listed on our website. Agapi Mesodiakaki from Aristotle University of Thessaloniki, Greece.
Yeah, hello everybody. Can you please share my slides because it just pops up a message about rights and it will take some time to open up again the WebEx.
Yes,
If not,
no
I can do
problem.
it and rejoin. Sorry for that.
No problem. Let me share my screen. If you can see my screen.
Not yet. Yeah, now yes.
Wonderful. So the floor is yours.
Thank you. So hello everybody. My name is Agapi Mesodiakaki and I'm a senior researcher with Aristotle University of Thessaloniki. If you go to the next slide. Okay, Aristotle University is the largest university in Greece, actually, and one of the oldest ones. It has quite a number of faculties and also schools as well as students. Go to the next slide. What I wanted to stress here is the numerous of campus facilities that the university possesses. Among them, I want to stress the Center for Disciplinary Research and Innovation, which actually our group belongs to. Our group is named Wireless and Photonic Systems and Networks, and as an abbreviation, WINFOS, and it's a collaboration between three different departments of the university. The Department of Physics, the Department of Informatics, and also the Electrical and Computer Engineering. Now it has more than 30 members, among them, of course, faculty members and also senior researchers. And we have quite a vast experience in European projects, actually SNS including, while being the coordinator in quite a lot of them. The next slide, please. So about our expertise, this spans across different domains. We start from nanometer scale, and we have plasmonics, integrated photonics, and also optical phased arrays, optical ramps. We go up to neuromorphic photonics and optical switching, optical interconnects, and we can reach kilometer scales, like beyond 5G and 6G fiber wireless networks. Go to the next slide, please. So let's go a little bit into more details about the optical communications. We were really happy some time ago to be the first worldwide that have built the fastest optical RAM, and we were in the news for that. Also, we have quite an experience in neuromorphic processing, silicon integrated photonics and plasmonics, and we're very experienced in evaluating and characterizing prototypes in our lab facilities. The next slide, please. Now, going into optical wireless systems, we have expertise on how to promote and develop system-level simulators like open source, like Omnet, as you see in the slide, and also MAC layer protocols for the fiber wireless links, but also performance analysis in this area of topics. Go to the next slide, please. And now we go to another really important topic where we have a subgroup working on, that is about integrated terrestrial, non-terrestrial networks. Here we develop both algorithms that can be of low complexity, but at the same time try to optimize the resource allocation in such a really complex setup. We have experience in field trials in this direction and also in test-bed evaluation. And here I have put some indicative interests that we have in SNS, but of course this is not a limited list. You go to the next slide. Now about our hardware, we have quite a well-equipped laboratory, as I said before. This includes components for the signal generation and signal reception and analysis, as well as other really powerful components that help us perform really interesting experiments. You go to the next one. And summarizing here, I have put, first of all, a picture of this well-equipped lab I said before, as well as some indicative projects that we have been working on and are still ongoing. You can find here our contact details, and we'll be very happy to search common ground for really nice synergies with all of you. Thank you very much. Yeah, I have more slides that you can find offline.
Thank you so much for your presentation. Now we give the floor to our next presenter, Božkan Vidošković from TUE.
Yes. Hello. Do you see my screen?
Not yet.
Okay, now it should come. Right.
Yes, thank you.
Okay, very good. So thank you for opportunity to present our work. So my name is Vojko Vidojković. I am professor at Eindhoven University of Technology, Department of Electrical Engineering. And today I will present the work that we do, let's say, in our RF Sensing and Communication Lab. We are part of the, let's say, larger group that does integrated circuits, but today we will talk about RF sensing and communication and what we can do in the scope of this call. So here is our approach. Our scope are, let's say, analog RF millimeter wave circuits for sensing and communication. And with our circuits, we address different applications. We see wireless communication, we see satellite communications, we do radar, automotive, drone-related or cross-section monitoring, and we also extend ourselves into medical. And let's say in these applications, we look key performance indicator like performance, form factor reduction on energy efficiency. And in our circuits, we are addressing high data rate, large bandwidth, high operating frequency, output power, and small form factor. With that, from that perspective, we fit very well within this call and let's say the branches that this call gives. Our vision is that from, let's say, concept via circuit and building blocks, we come to systems and to the demonstrator for certain application. So in our approach, we have 4 tracks. We have a design and validation, where we are centered around transceiver, and that's a main building block for the communication and sensing. We design different building blocks. We measure them, we validate our concept. We also develop the, let's say, design flow and tooling, because millimeter wave design is a little bit specific. So that's part of our research. And at the end, we end up with demonstrators demonstrating that we can satisfy the specifications of the application. And on this figure, we see 2 demonstrators. That's a phase modulated radar at 60 gigahertz. And also here we have a wireless communication link at 2.4 gigahertz. So from frequency, we address low frequency range below 10 gigahertz, but today we can, let's say, address the circuit design, validation, and measurement up to 300 gigahertz. So to convince that we are able to do that work, I'm showing some implemented ICs in our, let's say, lab, which are published. We have here 20 gigahertz transmitters, which are published at conference and in journals. We have a 60 gigahertz transmitters. We have 140 gigahertz multipliers. We also developed the method to measure, let's say, at high frequencies, and also, let's say, 70 dual band 7140 gigahertz power amplifier, which will be published. There are also more circuits in the pipeline for the design, for measurements, and also for publishing. Also, it's very important, as I mentioned, measurement and characterization. Here are our setups. It's also, let's say, to convince you that we are able to characterize and measure the circuit. We see 3 main setups until 110 gigahertz, 140, and also large signal measurement setup 110, 170 gigahertz. These facilities is in the lab and ready to be used. So finally, let's say about the collaboration. Our domain is front-end modules, which means integrated circuits operating in RF millimeter wave frequencies from ideas to validations. And we are addressing system, architectures, and circuits. And we are open for collaborations on high-speed communication and sensing, and some examples are antenna, signal processing, edge computing, or AI, including algorithms. You have a contact. If you are interested, please contact us for further discussion and collaboration. That's all. Thanks a lot.
Thank you so much for your presentation, much appreciated. And now we're going to give the floor to our next presenter, who is Mr. Edward Austin from Lancaster University. Are you with us? Wolfgang, can you please stop sharing your screen so that...
I just have to find the button for stop sharing.
Edward, are you with us?
Yes.
Yes. Edward? So apparently Edward is not online this afternoon. Then we move on to our next presenter, Yudani Riobo for Quobis.
Yes, can you hear me?
Yes, I can hear you. The floor is
Okay.
yours. Do you have access to presenting your presentation?
I'm going to share my screen. Let me know.
Yes, if you can put this in presentation mode.
Is it okay?
Yes, we can see that.
Okay, thank you so much.
Thank you.
And let me put my let me also put my camera. It doesn't work, the camera. Okay. I can. Sorry. Well, it doesn't matter. I'll start. Well, my name is Yudani Riobo. I'm the head innovation in Quobis. And well, Quobis is a leading SME in carrier-grade communication solutions for telcos and enterprises, and a proud member of the 6G Infrastructure Association. We focus on simplifying networks, cutting costs, and enabling smooth service integration for the 6G future. Quobis has been at the forefront of communications tech, starting with the first industry-grade WebRTC application server. And today we are building on that experience to help validate advanced 5G infrastructure, ensuring it's scalable, secure, and reliable. We support trials to integrate IoT, edge, and cloud in real-world key sectors, and also the definition of key metrics to measure impact in areas like emergency services and media. Quobis technology powers a broad range of use cases by delivering voice, video, and collaboration solutions in key areas such as private 5G networks, where high performance and low latency really matter, critical communications, especially for emergencies and disaster response, industrial IoT setups, helping monitor and control machines in real time, edge computing, where we boost efficiency and make the most of available resources, and compliance tailored to specific industries, handling unique legal and regulatory needs. Our R&D is closely aligned with this SNS goal, with a strong focus on real-world 6G validation and innovation. We are working now on testing 5G performance and interoperability in practical scenarios, building AI tools for real-time decisions that balance energy use and security, advancing orchestration for IoT and edge with fast and secure service deployment, enhancing real-time comms security through encryption and threat mitigation, and contributing to open source platforms to drive adoption and cross-sector innovation. For this call regarding Stream B, Quobis is ready to contribute in several key areas. We can ensure smooth, high-quality communication over mixed satellite ground systems, adapt protocols and architecture for full interoperability, or support critical use cases like direct-to-service and emergency services. Regarding Stream C, Quobis brings solid telco and cloud-native know-how to support 6G infrastructure and standards. We build a scalable cloud-based telco system that follow 6G principles like network slicing and edge computing. We contribute to open APIs like Camera and Open Gateway to make network integration smooth. And we also use AI for automating networks, managing traffic smartly, and boosting security with real-time threat detection. We also handle end-to-end validation with continuous testing and deployment. Regarding StreamD, we can add value by testing and validating 6G networks end-to-end, building cloud-native telco systems that support edge computing and open APIs, and making sure voice and video work smoothly across satellite and ground networks. We also use AI to automate tasks and enhance security, and actively contribute to industry standards to help drive 5G and 6G adoption across different sectors. To wrap up, at Quobis, we combine a strong expertise in real-time communication, secure architectures, and tailored solutions for different sectors that make us a solid partner for the next phase of SNS project. If you'd like to dive deeper, the full presentation includes more details about our capabilities for this call, along with real examples from past projects. And don't hesitate to get in touch if you want to chat more or explore ways we could work together. Thanks a lot for listening, and here you have my details.
Thank you very much for your presentation. Much appreciated. If you can please stop sharing the screen, we will give the floor to our next presenter. Our next presenter is Frank Gao from WAN.AI. Are you online? If you're online, you can start presenting your presentation. Frank?
I am online. I'll just
Wonderful.
very quickly
Welcome.
set this up. Share. Right, can you see my presentation?
Yes. Yes, please go ahead.
Hello?
Yes, Frank, we can see your presentation. You can go ahead.
Okay. So One.AI is a software company, and the product that we're building will allow enterprises to guarantee performance on a data connection level. Now, in use cases where there's a premium on performance, such as in industry and in manufacturing, these performance guarantees will create significant value through automation and increased productivity. And we will capture some of this value through a telecom SaaS business model. So our unique insight is that performance is the key to unlocking and enabling internet-based tech in industry and in manufacturing. In fact, as of 3GPP release 18, all 5G networks are mandated to report their end-to-end quality of service metrics in real time. And what we are doing with our technology is to be proactive by allowing for AI to maintain the 5G quality of service parameters. So we're currently a team of 2 co-founders and a tech team of 4. And our advisory board has been pivotal in helping us to execute on this idea. So 5G makes what we do possible because of its software-centric implementation strategy. Now, since 3GPP release 15, network functions are implemented on software as software running on general purpose hardware platforms. And this telecom cloud implementation strategy is now currently being deployed in private 5G networks in manufacturing and industry. But 5G itself is an evolutionary network rather than a single point solution that is industry ready. Now, one of the key problems is something that we're very much familiar with. So this buffering of video. In a private 5G networks, the robots are programmed to stop if their computer vision buffers, and this is out of safety reasons. So the main problem at the moment is that networks are built for human perception. So for example, 100 millisecond latency, and they're managed by humans. We are shifting this paradigm by designing networks that are suitable for machine perception, so 10 millisecond latency, and actually managed by machines, that is AI. Our MVP, which we are just about to launch, is a cloud native product and also AI native product that observes network traffic through traffic monitoring. It then computes the exact operation of internet protocols to determine the data demand. And it uses AI to reason about the best allocation of resources that delivers on the QoS specification. So key to our product and our technology is a compute capability, ultra-fast compute capability. Now, compared to legacy solutions such as OpNet, we're 250 times faster than such products at computing the exact operation of internet protocols. So if you use OpNet to model your network, it takes about an hour plus to model 5 minutes of network time on a 1 gigabit per second link. It only takes 1 AI 15 seconds to do the exact same computation. That's 2 orders of magnitude difference.
One small comment. I have 1 minute left.
Okay, I'll try and wrap up. Now, when it comes to training AI with synthetic data, one publication we've read took 4 days to generate the data to train AI to predict network traffic. Now, because one AI is 20 times faster than the real-time compute, those 4 days would only require 4 hours to fully train our AI models. So it's taken us 4 years to go from ideation through to prototype, and now we're building an MVP for the 6G sandbox. We're slightly late, but we're working on training the AI models to solve generic QoS environments and mechanisms. And that's our presentation. Would very much like to collaborate with anyone who's working on the 5G standalone networks. So we are core network technology, and we would very much like to collaborate with anyone out there with a shared interest. And we look forward to connecting. Thank you very much.
Thank you, Frank, for your presentation. If you can please stop sharing now, we are going to give the floor to our next presenter, Mr. David Crawford. Are you with us?
Hi there. Yes, I am with you.
Welcome.
I think I'm maybe sharing the wrong presentation. No, let me just.
The floor is yours if you want to present that presentation.
Yeah, thank you. Okay, so if I go to full screen. So I think you should be able to see full screen mode now.
Yes, indeed.
Good. Okay, thanks. Okay, so yeah, afternoon, everyone. I'm David Crawford. I'm the 5G Project Director at the University of Strathclyde. And we have what we call the Strath SDR, or Strathclyde Software Defined Radio Lab. And essentially, we are some roughly 20 staff, including 4 senior academics and academic-related staff, and a number of research staff and PhD students and various interns and so on. We've been around since 2010, so we're about 15 years old, and we've been working in various technologies related to software-defined radio, all the way through the various Gs, up to 5G, of course, most recently, and looking towards 6G now. We also have a spin-out company, Neutral Wireless, which my colleague will talk about in the next presentation. And the idea of that is basically that's the kind of commercialization of a lot of the work that's been done within the university Strath SDR group. So we look at a number of different themes going. We obviously we're software-defined radio focused, and a lot of that is done on FPGA-based systems, particularly the AMD /Xilinx RF SOC device. We look at communications algorithms. We are very much into spectrum sharing, particularly dynamic spectrum sharing and efficient spectrum management, and machine learning for and AI for efficient spectrum management of spectrum. We have quite a number of years of experience in designing and developing various algorithms on SDR platforms, and in fact we have a number of publications, textbook publications, very kind of practical engineering textbook publications based on our years of just experience and learning of how to kind of get things up and running on the software-defined radio platforms and so on. In fact, most of these textbooks, incidentally, are available free of charge as PDF, in PDF format, as ebooks. They can be purchased as hardbacks, of those proper paperback, but as an ebook, that most of them are available free of charge online. But another area that we look at is private networks. And one of the key things there is that we recognize that there is a number of use cases, a number of applications, particularly broadcasting, entertainment, sports, rural, and various other applications where private networks can offer and do offer certain connectivity features that are not necessarily available with the public networks, either because of coverage issues or because of feature issues. And of course, one of the key things, if you're implementing any network, but particularly with private networks, you need spectrum. And so one of the key things we're working on is dynamic spectrum management, agile dynamic spectrum for various kind of private networks. Quite a lot of them kind of pop-up networks that pop up for a weekend or a week or a couple of days and then back down again. And so we're working very closely with regulators and other organizations on looking at how we can make spectrum much more efficient and spectrum management much more efficient. We have been involved in a number of key projects over the years, ranging from, on the left-hand side, rural communications, going through to underground rail communications, again, rural internet access in various countries in Africa, broadcast, and also we took part in the recent TUDA project where we looked at spectrum sharing between NTN and TN networks. And right now, a key project that we're working on at the moment is exactly that, looking at how do we optimize the spectrum management for private networks and make private networks easier and more cost effective to implement. So in terms of the SNS, we're looking to participate in projects relating to a number of areas: spectrum management, private networks deployment and design, software-defined radio, terrestrial networks and non-terrestrial network sharing, and that kind of thing. And we do have access to well-established team, experience of working in large projects, various facilities, and obviously access to our commercial spin-out company, Neutral Wireless. So thank you very much.
Thank you very much for your presentation, much appreciated. Now we're going to move on to our next speaker, Mr. Damien Muir from Neural Wireless. If you are online with us, the floor is yours.
Yes. Okay, are you able to see my screen now? Yeah.
Yes, indeed.
Okay.
Please.
So I think you might have had a sneak peek of these slides just now, but I'll continue on anyway. So Neutral Wireless are a spin-out company of the Software Defined Research Lab from University of Strathclyde in Glasgow. As David has already touched on, we do offer engineering consultancy and support for FPGA, system on chip, Zinc, MP-SOC, RF-SOC systems. David's already touched on the textbook you can go and find. We've got a lot of experience in this area. We've got a very strong relationship with AMD. And through that, in that heritage that we have over 15 years of working PhD students together, forming this company together, we have started offering out end-to-end private 5G solutions to a range of industries. So we kind of started this in 2021, I want to say. So on the left there, you will find our kind of flagship product back then, which was the Loman Network in a Box. Through engagement with people in industry, particularly the broadcast sector, we found that although this is a great bit of kit for a lab environment and remains so to this day, if you're deploying this kind of network outside, then unfortunately, especially in Scotland, it rains. And there are some bits of kit you don't want to get wet, and so disaggregating the network in that way is much more suitable for a lot of those use cases. Hence our new product on the right, which is a briefcase style software-defined radio. The reason I bring up the broadcast sector is this is where we kind of targeted initially when we spun out. So I think as of now, we have had something like 1 billion views of live broadcasts that have been facilitated over our private 5G networks. And I'll take you a little bit through that just now. I won't spend too much time on this timeline. You can find it online. But in 2021, we went down to London for the MotoGP in Silverstone. That was the first time, to my knowledge, that anyone had ever took a live video stream that was broadcast over a 5G SA network and put it out to commercial viewing. From there, we thought, okay, we have something. In 2022, we went around the world. We went to Ireland, Kenya, New Zealand. And what we wanted to test there was backhaul, because we like to say we are agnostic to backhaul. So we tested 5G networks backhauled over LEO satellite, over point-to-point microwave links, and in all cases got a live broadcast shown to the consumers. Fast forward to 2023, we popped up the world's largest temporary 5G SA network for broadcast purposes, where we put up 7 cells across 3 kilometres from Buckingham Palace down the Mall for the coronation of King Charles. We had, I think, 60 devices streaming video from 20 of the world's largest broadcasters. And from there, it's strength to strength. In 2023, 2024, we focused more on integrating tightly with the industries that would be looking to use private 5G networks. Why would we do that? Well, private 5G, unfortunately, has a bit of a reputation from initial hype of being a solution in search of a problem. So what we wanted to do is we wanted to target use cases that would need the benefits we can offer. We can offer uplink biased networks through configuring the TDD frame structure, a benefit of software-defined radio. And we can offer ultra-low latency of sub 20 milliseconds, which are very useful for low latency video streaming, and the broadcasters need that to cut between wired and wireless cameras. Last summer, we attended a large sporting event in Paris where we beat our own record for the largest temporary network. We had 220 simultaneously streaming 1080p footage from a certain opening ceremony. And that wasn't the only deployment we did in Paris. We had 3 different stadiums and also a network at sea in Marseille, where we backhauled over a 6 gigahertz Wi-Fi link. And across 3 different boats had 3 different G-Node Bs providing footage of the sailors from Samsung handsets strapped to the boats themselves. This year, and for the last 2 years actually, we've been working on the On-Side project, again engaging really tightly with industry to better understand, okay, what are the commercial realities of private 5G? We can make this as affordable as we like, and we're trying to do it, we're optimizing that, but at the end of the day, mobile equipment is expensive. So if we are bringing that kit to you, how does it make you money? How does it save you money? And we're engaging with football stadiums, manufacturing centres, ports, festivals, local councils, all to try and suss out where is the commercial win in deploying private 5G. We're looking at that across Glasgow and the north of England, and we're also looking at, as David has touched on, in the spectrum allocation challenge. There's two parts to that. There is network co-allocation. So if you have two private 5G networks together, close by physically, do they interfere? When do they interfere? How do you prevent it? Similarly, if you have private 5G network nearby a high power, high tower MNO network, do you interfere with them? The answer is always kind of no, because of the power differential. But do they interfere with you? They can do, especially if it's in-band interference. Thank you. So looking at that, looking at ways to minimise that and break down the cost barrier, find out where it commercially makes sense to deploy these networks. When it doesn't, look at how you can sweat an asset to make more money for a customer, look at how you can stack use cases to make it make sense. And the takeaway here is we are deploying real networks in real industries across Scotland, the UK and Europe at the minute. We want to continue doing that, but there is a barrier to entry at the minute. And so we would like to be the guys who help take from the lower TRL levels up to what a customer can understand. And I guess especially for Stream D for the SNS JU, that would be something that we would particularly like to explore here. So please do get in contact. My email address is at the start of this slide, or you can reach out via our website.
Thank you so much for your presentation and for your time. We now give the floor to our next speaker, Aparajitan Sivanathan from Advanced Manufacturing Research Center. Are you with us this afternoon?
Hello everyone, my name is Wahab. I'll be presenting on his Siva's behalf. So I'm going to share my screen. It will be a video which will cover our today's pitch. Can you all see my screen?
Yes.
AMRC is a lead. Are you getting the audio as well, nice and clear? Of the video?
Yes, we did.
Okay, cool. I'll start the video.
Research organization dedicated to advanced manufacturing. We're led by our industrial members, which include companies from across the supply chain, spanning aerospace and other high-value manufacturing and engineering sectors, from global corporations to local SMEs. With over 500 expert researchers and engineers, we operate across 3 UK sites, delivering cutting-edge innovation in everything from composites and castings to additive manufacturing and machining. Next-generation wireless connectivity is crucial for the manufacturing industry and other sectors. At the Advanced Manufacturing Research Center, we have a state-of-the-art research network called SWALE. This network includes 5G, Wi-Fi 6, millimeter wave, and high-speed wire technology. AMRC also has a powerful on-site high-performance computing cluster with 800 CPU cores and 88,000 GPU cores. This cluster accelerates smart factory industrial use cases, including real-time machining, hybrid reality machine vision, autonomous robotic assembly cell, and Spot for remote factory inspection. We generate digital step-by-step work instructions and insights for planned work and production schedules, creating a smart factory environment using Dassault Systems 5G integrated with MES toolchain. AMRC is also part of 5G ACIA testbed. It focuses on TSN over 5G for the manufacturing and automation industry. AMRC hosts the largest 5G manufacturing testbed in the UK, spanning 8 sites. This testbed includes various 5G solutions like Nokia's enterprise-grade private 5G, Open RAN, and fully open-source 5G. Our open-source Beyond 5G solution features a real-time intelligent controller. This technology offers network slicing, enables network segments tailored for specific manufacturing process requirements. For industrial connectivity, AMRC has developed native 5G devices equipped with manufacturing interfaces such as Modbus, PCI Express, and onboard edge processing capabilities. These devices meet the diverse needs of modern manufacturing environments. The Bombas platform collects high-speed data from various machinery, industrial operations, and smart power sockets. It helps improve energy efficiency, reduce carbon footprints, and enable intelligent automation for manufacturers. In cybersecurity, the AMRC team has created an innovative tool called Cyber Falcon. It collects information from various metrics and profile devices based on multiple parameters including network traffic, power consumption, and asset movement on the factory floor. The team has also deployed other open-source tools for managing network performance, such as Zabbix and Siamast. AMRC is planning to build a distributed manufacturing cloud that integrates the manufacturing execution systems with blockchain for enhanced security, transparency, and efficiency in manufacturing processes. Join us at AMRC, where we are accelerating the future of industrial connectivity.
Yep, thank you very much. If you want to contact us, these are our contact details. Thank you very much.
Thank you very much for your video presentation and for your intervention. Much appreciated. We now give the floor to our next speaker, Laurent from Canon Research Center France. Are you with us?
Yes.
Welcome.
Can you hear me?
Yes, I can hear you and I can see your presentation. The floor is yours.
Great. Good afternoon, everyone. And before starting, let me thank the organization team for their kindness and flexibility to support our last-minute request. Let's go with the presentation of the Canon Research Center France. So we are a Canon Group company, basically involved in the global R&D inside the Canon Group. So means having some connection with various Canon R&D organization, in particular in Japan, Canon Inc., medical, and when it comes to Europe, related to video surveillance and network camera, access communications, and a milestone system to lower extent. So we are definitely 100% Canon Group affiliated company, means we will have to challenge providing those guarantees with regard to the eligibility conditions for the Stream D. What we are quite confident we will succeed to do this. Indeed, we are already 35 years old organization established in French organization, already dealing a lot with all those matter. So we are quite active in standardization inside those organizations, contributing to those standards in imaging and networking domain, including Wi-Fi and 3GPP. We are 50 people. That shows our current activity inside Horizon Europe. So we are quite active actually in the intelligent transport system. That's the cluster 5, in particular CCAM domain. But steadily now we are shifting to the cluster 4, and we are having one project in AI, data, and robotics, and we are pushing hard now to be part of some SNS action. And those are kind of a picture of what we are contributing to in the CCAM. Verticals we are aiming out, so industry, that's basically about process monitoring and monitoring as well show flow for the HEV and AMR, logistic and CITS, emergency safety services related to video surveillance, and healthcare by using a network camera. Type example of assets we can bring to the project and actions related to the analytics for a camera, in particular in the beyond detection, identification. There is also those stuff of measuring 3D depth information and combining with other type of sensor. Synchronization for network camera by using TSN, and we are also doing simulation on the 5G new radio PHY, in particular related to ISAC. Our technology of interest for this call, in particular, number one, I would say the higher in the priority here, that's related to ISAC, having a multi-sensing, multi-static sensing by introducing UE in the loop. Of course, bitrate control and efficient video streaming is also of interest for us, and new PHY techniques enabling multi-camera systems, so uplink densification, and of course AI-based. We understand the 6G as a big computing power to be growing the capability of our network camera. The call we are interested in, probably stream B002 related to wireless communication, and stream D are the most appropriate for us. And for this, those are the type of contribution we can have. And just to finish, here is one example of how we see the contribution of the camera to sensing on ISAC, let's say based on what the result that has been achieved inside the X2 projects. That's it. Maybe that's times for me to shut down.
Thank you so much for your presentation. Much
Welcome.
appreciated. Now we move on to our next speaker, Janez Sterli from the Internet Institute, if you are with us this afternoon.
Yeah, hello from Slovenia.
Hello, welcome. You can share your screen and
just
have a look at your presentation.
Okay, I hope you see my slides.
Yes, indeed. Please,
so perfect.
The floor is yours.
So greetings from Slovenia again. First, many thanks to the SNS team for giving us the opportunity to present our company. So I'm Janez Sterli and I'm featuring the Internet Institute. So we are an SME and university spin-out located in Ljubljana. We target 5G and 6G solutions for critical sectors such as sports, safety, industry 4.0, and smart factories. As a trusted research and innovation partner, we have a strong, let's say, track record in EU-driven 5G and 6G development. We are for sure a proud member of 6G SNS Industrial Association and other 5G-related activities, such as NATO Lock Shield, cyber exercise, and so on. Currently, we are involved in several development projects where we actually tailor our product portfolio for beyond 5G, of course, solutions. So we have actually 4 product pillars in our portfolio, all built with cutting-edge 5G technologies and cloud-native principles. So basically, the first one is Simon. It is a crowdsourced internet service quality monitoring platform, a toolset targeting crowdsourced monitoring of service quality across mobile, fixed, cloud networks. The platform is actually open source and we have available open data. Actually, data goes back for several years. That can be also used as a training data set for AI and other, let's say, optimizations. Another solution is QMON. So QMON is a 5G test automation solution. It is our industrial grade platform for continuous 5G and 6G mobile network monitoring. It integrates more than 100 KPIs, including power consumption data. So we collect the performance and energy related data on end-to-end basis from UI to RAN to core network and cloud. And based on that, you can imagine we can build a user network, all services, digital twins. As an example, let's say you can see it here on the figure. Basically, we can build a 3D model of a base station propagation if needed. So another two products are the Armon, is our industrial grade IoT platform. It is designed for automating IoT processes in harsh environment, featuring 5G gateway, Modbus functionality, far edge, IaaS, compute, etc. So basically, it is really a platform for providing a reliable zero data loss telemetry layer to collect data, let's say, from industrial installations, sensing environment, and so on. And the final one is our mobile one. It is actually a private 5G solution, a fully cloud native system with a disaggregated RAN, supporting containerized BBU and core network deployment. It actually enables rapid deployment and redeployment of our system in under the 1 minute. So it is fully softwareized platform that we actually open to our partners to fully control it. If I give you an example, if you have, I don't know, an application orchestrator, you can actually control also the power, let's say, on the port of the base station. To support our global collaboration and also internal, of course, R&D, we have built a 6G-ready experimentation facility in Ljubljana with dedicated 5G spectrum. We fully control, as you can imagine, the compute, storage, 5G connectivity. We have integrated test automation toolset, IoT devices, drones, and so on. Through our collaboration in 6G development project, we have extended the capabilities of our testbed, let's say, to monitor power consumption on end-to-end basis, which means that we can profile user, mobile system services from energy consumption perspective. So based on what we are able to aggregate and store, let's say, from mobile parameters, radio and core network, we can actually build, let's say, a data warehouse where we can learn, let's say, from the past, understand the present, and of course, also we can predict the future. So this is actually our, let's say, large data set, which we are actually, let's say, exposing to our partners to develop IoT-driven intelligence and other, let's say, 6G optimization, let's say, functionalities. So this is my last slide. So we are seeking for new partnerships and collaboration. Our strength lies in end-to-end testing, quality testing automation, 6G energy optimization, portable networks, and for sure mission-critical IoT systems. So we can also bring Slovenia or international partners to deploy 6G use cases in really industrial environments. So thank you, and I look forward for future collaborations with all of you. That's it from my side.
Thank you very much for your presentation, much appreciated. We give the floor now to Michael Parker from the University of Essex. Michael, are you with us? We can see your screen. I cannot hear you.
My apologies, I couldn't find the unmute button. So
no problem. I can hear you now. If you can please
great.
put your presentation.
Thank you, Anna, and
mode.
thank you very much for the opportunity to present University of Essex to everyone here this afternoon, and thank you for waiting towards the end. My name's Mike Parker from the University of Essex, working with Professor Stuart Walker in the Access Networking group, and we've been working in access networking, next generation technologies for a long time. We have a fully equipped laboratory with the latest measurement equipment for millimeter wave and sub-terahertz frequencies and wavelengths, and we're particularly specializing in wireless and optical technologies for future access networking infrastructures, with also interest in high energy efficient technologies based on energy harvesting and low power designs. And we also do a lot of using AI to optimize networks as well. And recently we've added millimeter wave, including integrated circuits and antennas to our capabilities. So in recent years, and currently we have involved in a variety of projects across the EU. Currently, actually, we have a project Circubat, where we're integrating AI with data analytics and massive IoT technologies for very specific application for EV battery recycling. But more recently, we've just completed a project Sambus on sustainable and adaptive ultra-high capacity microbase stations, and it's just ERA Horizon Europe call. And we do have an interest also actually in security with QKD, and then we've been involved in previous projects with Metro Hall and 5G Charisma in previous call. And just to, we've had various papers published on our work coming from the laboratory in CRAN and optical fronthaul latency aspects for when considering different next generation network topologies, including aspects such as cell site densification with millimeter wave and sub-terahertz line of sight designs, and general optimization of cloud RAN architectures. So what I was particularly wanting to introduce to you is that at Essex, we are actually developing at a preliminary state a project proposal, which we would like to submit, called Hathor, which is hybrid architectures with highly energy efficient, high capacity optical radio networks using our advanced 6G technologies in millimeter wave and sub-terahertz, and also aspects of energy efficiency and using AI for network optimization and building on our expertise in CRAN and optical wireless fronthaul latency and densification. So we do have core partners, but we actually are looking for additional partners as well. So we haven't quite decided yet which stream to go for, but for anyone who's interested in joining us in Hathor, my email and Professor Walker's email are down below as well, and we'd be very pleased to hear from you. Okay, thank you very much.
Thank you so much for your presentation. We give the floor now to Zubair Shaikh from AI.
Hi, I'm Shriram. I'll be presenting on behalf of Zubair today.
Yes, please.
Yeah, so just give me a second. I hope you can see the screen.
Yes, but we cannot see the presentation now. Yes, thank you.
Yeah. Okay, so first of all, I would like to thank the organizers for this opportunity. So I'm Shriram. I'm a senior engineer at IVIDA. So first of all, let me introduce IVIDA to you. It was founded in 2021 with a vision of revolutionizing and redefining private 5G networks. It is actually a spin-off of the Integrated Communication Systems Group here at Technical University of Ilmenau in Germany. The company delivers network management solutions for different industrial environments, which helps the customers to configure, manage, orchestrate, and optimize their private 5G deployments in a vendor agnostic manner, and also incorporating AI-based automation and also promoting energy efficiency. So the SMO itself is a flexible, scalable, and microservice-based solution for the end-to-end orchestration and management of a private 5G network. So the SMO itself, under its umbrella, is managing multiple domains, namely automation, DevOps automation, for the efficient rollouts, testing, and configuration of different network functions. It also takes care of the configuration and orchestration of different infrastructural elements, including cloud as well as edge servers, and also virtual network functions, which forms as part of the core as well as the RAN, radio access network. And it also takes care of the containerized network functions with the help of Helm, Kubernetes, and Docker. Now, the SMO itself is the core context for the end-to-end lifecycle management, and it provides an FCAPS-based management platform for different networking elements. And it is designed in a vendor-agnostic manner such that it can work with multiple vendors with the help of multiple interfaces, of course, including the Open RAN defined interfaces such as O1, O2, and also interfaces such as Netconf, REST, gRPC, etc. And the software itself also extends its support to open source based solutions such as SRS RAN, Open Air Interface, Open 5G core network, etc. So the research group itself has been working on different network optimization algorithms for the past 20 years, both heuristic as well as AI-driven algorithms, integrating zone concepts for different use cases such as coverage and capacity optimization, mobility, load balancing, the network slicing, energy savings, etc. And we are also extending these algorithms for the supporting Open RAN-based networks in the form of XApps and RApps right now. And another interesting aspect that we are working on right now is the intent-driven network management utilizing the LLMs, utilizing the power of LLMs. And in order to support these RApps, we have also developed non-real-time RIG, which is right now in tier level 4, and which is conforming to the Open RAN technical specifications. It also comes with its own A1 interface and R1 interface, which facilitates the communication with third-party RApps as well as third-party near real-time rigs for further network optimization use cases. And these are some of the projects that we are working on, both funded by the German federal government as well as the Thüringen state government. And on the right side, you can see a set of companies that we are partnering with right now. And currently for the SNS JU call, we are particularly interested in the Stream B. And if you are interested, please feel free to contact us in the following email, or we are also active on LinkedIn. Please visit our webpage as well. Thank you.
Thank you so much for your presentation and for your time. Now, I understand from the chat that Gary is online and from AWTG and could also have his presentation at this moment in time. Gary, can you hear me?
I can hear you, yes. Can you hear me?
Yes.
Okay, fantastic. All right, thank you for allowing me to jump in, and apologies for missing the earlier slot.
No problem, you can share your screen.
Okie dokie, just let me know when that's showing. Just 1 second. Okay, is that showing okay?
Yes, indeed.
Okay, thank you very much indeed. So yeah, thanks for your time. So I'm Gary, I work at AWTG. I work in the bid team and also look after business development. So AWTG was founded in 2006. So we're a tech company and we provide end-to-end solutions around 5G, AI, smart cities, and many, many things. So as you can see from this slide here, we've got many customers and partnerships across the public sector in the UK. So the regional, local government, central government. We also work extensively with private operators, mobile network operators, the healthcare sector, various industry bodies, various universities and research organizations. We're a trusted partner by these organizations. We built the UK's first 5G testbed in 2014 at the University of Surrey, and we design and deploy 5G networks globally. So just some key facts and figures. We have 120 plus engineers, software developers. We have recognitions for providing fantastic customer service. We've been in the business some 19 years, and we are on an array of frameworks which give us access to various projects. Our innovations are many. So most recently, we have an agentic AI solution, which we developed in-house called Kai, and we've provided smart city solutions. We've utilized IoT sensors with our AI and our connectivity solutions in agri-tech. We have many certifications, as you can see, and we have expertise across not just 5G, Wi-Fi, the cloud, web design, apps, microservices, and we have delivered over 5,000 networks. So again, just to show our sort of breadth of expertise and services, so we provide solutions across connectivity, software innovation, and we also provide advice to a whole array of organizations, including smart ports. We are working with colleagues in Europe around a potential application using this funding. We've worked with many universities and UK bodies, as you can see. And we've also created and led many global consortiums. We've secured funding from various bodies, from the UK government, Innovate UK, Horizon Europe, the European Space Programme. And we've delivered some really large projects and innovation across logistics, transport, manufacturing, healthcare, gaming, and tourism. So we do have a very wide range of expertise and success. And yeah, just to wrap up, we've successfully led and managed some large consortiums such as Sconda, which delivered 5G O-RAN in Glasgow city centre, a really high demand dense area. We've also led the Tudor project, which was around interoperability of a 3D network, terrestrial space, high altitude platforms for 6G applications. We've delivered a neural host in Cambridge, and again in a high demand densely populated area. And we've also worked innovation hubs and others in Scotland and across the UK and across Europe. And that concludes my presentation. Please do reach out to me if you have any questions, if you'd like to collaborate, you'd like to learn more. We're very happy to help, and thank you for allowing me the time.
Thank you so much for your presentation. We now move on to, I believe it will be the last speaker of today's session, Mr. Edward Austin from Lancaster University.
Hi everyone. Thank you for giving me the
Hello.
chance to present. I will share my screen.
Yes, please.
Allow. Can everyone see my screen? Or is it still black?
Yes.
Perfect. Excellent. In that case, I will go full screen and carry on. Okay. So hi everyone. Yeah, I'm Edward Austin from Lancaster University's Network Group. I'm here to talk to you today about some of the opportunities that we see and are interested in for the proposals. So a very long-running university school. We've got a proud history of applied open source research with collaborations all across industry. BT, BBC, and NCSC and GCHQ are currently ongoing. We've had ones in the past with companies like Toshiba and BAE. And sort of our themes are centered around media delivery, software-defined and intent-based networking, the management, the orchestration, and so on. We have a particular specialism over the last few years working on projects like the NGCDI and TUDA, looking at 5 and 6G mobile communications. And an underpinning theme for all that is security and resilience. And we've got a wide range of testbed capabilities, an RCS lab, a 5G RAN core. We've also got ourselves a small-scale cloud SDN network too. And we actively participate in various standardization bodies like the IETF. So these are some of the projects we've worked on for the last sort of 10 years or so. And I'll just talk in some detail about the areas which are of particular interest and thriving at Lancaster today. Probably the biggest one in terms of 5G, 6G, and in particular terrestrial, non-terrestrial network integration, built off back of things like TUDA, is the intent-based networking. And we actually have our own system that can spin up intent-based intent-based intents, bad choice of words, and it can set up various networks to specification automatically. We presented that system at NOMS quite recently. And built into that, we're looking at some of the more AI-based focuses on real-time intent-driven telemetry, so actually having intent collect and then the system react to information being obtained in the network, and also sort of automated and intelligent slicing, automated intelligent deployment of services, and very much, I think it's probably obvious, the strong combination between AI, especially LLMs, and intent, and what that actually looks like in your network. Linked to this is perhaps, and this is very much again related to the AI theme, is on anomaly detection more generally, and that is security in the network, with tools we've developed like Tennyson that are targeting the precise location network you want to monitor, very lightweight, looking for network anomalies, and also more mathematical and probabilistic AI tools that we've recently developed, looking for anomalous behavior in data like network telemetry or energy usage across the network. One of those is currently deployed monitoring part of the UK's 5G estate. So there's a strong tie-in with the anomaly detection work to ensure a resilient or secure network and 5 and 6G. And work on that continues on. And I suppose linked to this, I mentioned some of the work we've been doing with UK government, is that there's also a sense we're building of cyber security at scale and supporting the human in the loop in that with, again, things like LLMs. And so there's a strong track record, not just with methods that can identify problems in the network from a more classical sense, like an intrusion detection style thing, or a mathematical monitoring telemetry kind of thing, but using the cutting edge technologies and supporting and how you're using as well, I suppose, how you deploy that LLM capability to parse problems that are detected and pass them back to the human in the loop to then make decisions on, is the network under attack? Is there some problem that needs rectifying? Making decisions back of the anomaly detection, basically. The final use case, and pivoting away from sort of network automated orchestration and the monitoring side, comes around intelligent media delivery. We're part of the AI for Me Prosperity Partnership with Surrey and the BBC currently, looking at delivering a different kind of media, I suppose. So traditional media, it comes as a fixed package broadcast content. Everyone gets the same thing, no matter what device, no matter who they are, no matter what their preferences are. In the future, there's a capability to deliver personalized media experiences by delivering the media in sort of pieces, objects, and piecing it together, be that at the edge somewhere, if it's delivered over 5 or 6G, centrally in the cloud or from some hub in a data center, or indeed on the user's device. And obviously, one of the things that fits with the calls is how to do that reliably at scale and intelligently. Will it be an AI-powered orchestrator, for example? So there's sort of the use cases we see in our ongoing research. And just to reiterate that testbed capability, the 5, 6G indoor testbed, several clusters, and an ICS system too, which has been very useful for some of the security side of things recently. And we also have a prototype video delivery system for that object-based media system I talked about with the BBC. And I've put there some of the calls that we think we could contribute well to and our interests, just in the bottom of the slide. So thank you very much for listening and giving me the chance to present. And I suppose I hope you all have a good weekend, given I'm the last.
Thank you so much, Ed, for your presentation, and I would like to take the opportunity to thank indeed all the presenters of this session and the previous session, and for your constant attention. It has been quite a long day with the info day in the morning and the brokerage in the afternoon. So I found the day very inspiring, with a lot of information, very rich information that has been shared, and I believe that has been equally useful for you. Of course, you're welcome to continue the conversation in the brokerage platform. As David Kennedy, our colleague from Euroscom, was mentioning, you can certainly add a profile and browse and search the submitted profiles online, and you have the link in the chat. I would also like to inform you that indeed the presentations are now on the website of this session, and of course of the sessions beforehand. And the recording of the day will be available as early as next week. With this, I would like to thank you so much for your time and for your efforts, and to wish you the very best of luck with your applications for our call, and to wish you indeed a very, very good weekend. Thank you very much, and have a nice afternoon. Bye.
Thank you. Bye, everyone. Thank you very much. Bye.
Thank you.